Hello, and thank you for your interest in this course. I'm very excited about it. This is something that people have been asking me to do for a while, and I've wanted to do it. I think there's a lot of interest in it, and I think it can potentially help a lot of people. And there's also a lot of confusion about what it actually means to host a database in the cloud and how to use it, and what it means to use Google Mapping APIs and how to get started. This course is a little bit different than my other courses in that it is not strictly open source. There are charges for using some of Google's services, but some are completely free. Others have a free tier, which means that you can use them for free up to a certain amount of usage, after which there might be charges. But I found Google to be very generous with their free tier. You can do a lot with what they offer you for free. Google makes billions and billions and billions of dollars off large companies, so they don't need a nickel and dime us small guys. Now, there are some premium services that normally have a charge associated with them, but they seem to be fairly reasonable. And all new users get a $300 credit that they can use to try out the services over a 90-day period and see how they work. They can also see how much their typical levels of use will cost, and then you can decide if you want to authorize Google to start billing. Until then, there won't be any charges, so you can complete this course and a lot more for free. But we will be discussing the cost of using these products throughout the course. The first section of this course will focus on the Google Cloud Platform. And for what it's worth, the cloud just means that you're using someone else's servers. They may put a fancy user interface on it and shield you from many of the technical details, but rest assured that you are just renting space on Google's computers and using their infrastructure rather than your own. And there's a lot of reasons why that might be beneficial. Now, the core of the Google Cloud Platform is probably going to be Cloud SQL. Cloud SQL offers the ability to set up a PostGIS instance on Google's computers, and you can be up and running in about 15 minutes. And you can connect to your instance of Cloud SQL from a variety of clients, including pgadmin 4 for typical database administration and querying tasks, especially for non-spatial data. You can connect from QGIS for creating and managing spatial data, and a variety of other clients such as web mapping and mobile applications. You can even connect to it from ArcGIS, and with ArcGIS you can't edit the data, but you can display it and use it as inputs to analysis, etc. And not being able to edit it is not as big of an issue as you think, because you can always download QGIS for free and use QGIS for editing, even if you want to use the inputs for analysis in ArcGIS. And QGIS is very good at editing PostGIS data. That was the reason that QGIS was created in the first place. Now, if you have no idea what PostGIS is and why you'd want to use it, you should. It will change your life as a geospatial professional. And I have an entire 12.5-hour course available on Udemy that will explain it all to you in great detail, and I highly recommend that as a prerequisite for this course, because PostGIS is used in almost all of the other applications. We'll also talk about BigQuery, which Google calls a data warehouse, and it has the ability to store and analyze petabytes of data at a time. But the interface will look and feel a lot like PostGIS because it uses SQL queries and it has a lot of spatial functions that I hope you're familiar with in PostGIS. If you have queries that are taking a long time in PostGIS, you can migrate the data to BigQuery and run your queries there, and Google will throw as many processors and as much memory as you need to process your query very quickly. Cloud storage allows you to store unlimited amounts of data in the cloud. Think of it as a heavy-duty Google Drive with unlimited storage. But like almost all of Google's cloud products, you only pay for what you use. And while you can use the Google Cloud Platform from a web-based graphical user interface called the Cloud Console, there's also a shell window where you can execute all of the Google Cloud Platform functions from a command line using Linux-like commands, and you can write scripts to automate processes, which we'll do in this course. It's a very handy and very powerful thing. And because the Cloud Console is web-based, you can do this from any browser, anywhere, at any time. Now, full disclosure, as of April 11th, 2022, this is where this course ends, with the exception of a section on Data Studio. I expect to add the rest of the modules in May and June of 2022, but it's already a 6.5-hour course, and people have been literally begging me for it. So I'm releasing it now so they can get started, as it currently covers the most important information that you'll need to get started using the Google Cloud Platform for geospatial applications. Next, we'll talk about Google Data Lab, which is a Jupyter Notebook environment hosted in the cloud. So you can use Google's computers for geospatial analysis, machine learning, and artificial intelligence using Jupyter Notebooks. And if you don't know what Jupyter Notebooks are, I highly recommend them. They allow you to combine text and interactive Python code to fully duct your entire analysis, process it, view the output, and share them with other people. I'm not sure if we'll talk about Compute Engine. That might be an entirely different course, but it's basically a virtual server that is fully managed by you, on which you can install a web server or a database or a development environment, for instance with Python. And using Google's computers allows you to develop in a completely separate environment from your organization's servers, so you can't mess anything up. And if you have large analytical tasks, it won't bog down your system. And they do have a free tier for the Google Compute Engine, and so you could even host small websites with their own databases for free, and expand into a more powerful engine if the time comes when you need to. And throughout the course, we'll be discussing security issues, including Google's identity and access management system, which allows you fine-grained control over who has access to your cloud environment and exactly what they're allowed to do. And full disclosure, I'm far from a security expert, and that's not the focus of this course. If this is a concern for you, I highly recommend that you find a security consultant to discuss your personal needs. But I will tell you what I know. That'll be enough to get you up and running in the meantime. Okay, that's about it with the Google Cloud Platform. I think that everything that we discuss in the section on the Google Cloud could also be done using other major cloud service providers like Amazon Web Service or Microsoft Azure. They all offer similar cloud services, and although I focus on the Google Cloud Platform in this course, the concepts that are discussed will be applicable to other services, and I believe that what you learn in this course will make using the other services easier if you choose to go that route. But Google also has some other tools that, to my knowledge, are unique, or at least far superior to what other companies offer, and they all work together, so I've become a fan of Google products for geospatial applications, and that's why I developed this course. Now, Google has some very useful analytical tools available that you can use for free, and that's always good. I like free. Data Studio allows you to connect to your data in a spreadsheet or a database, including PostGIS and BigQuery, and create attractive dashboards that can be shared with other people, such as a client or a project manager who doesn't want to deal with the complexities of desktop GIS. And I've been so impressed with Data Studio that I included 13 lectures and 2.5 hours of this course to it, because I kept finding cool features that I wanted to share. Now, there are other courses available on Data Studio, but none of the ones that I've seen discuss the mapping capabilities in much detail, and the mapping capabilities are pretty impressive, and that's what I focus on because this course is for geospatial applications. I found that I can put together a dashboard in a few minutes that would take a few days to code using typical web technology, and best of all, you can share the finished dashboards and let Google deal with the authorization and security. So Data Studio allows you to create fairly intricate dashboards. Oftentimes you'll see like a pie chart or a time series plot or something like that, but you can also do maps. That's what I'm going to focus on for this course. And so you can share a dashboard like this with your client, and they'll be able to do some filtering, for instance, by the status of a bird nesting area or a specific project number. And however they decide to filter, the maps will zoom in automatically to just the data that's showing up above. You can have multiple pages in your dashboard. And man, I wish this had been available 10 years ago when I was working on a lot of projects that would have really benefited from this technology. It sure would have made my life a whole lot easier. And the data that we're looking at in that dashboard comes from BigQuery, and it's based on a data flow that is kind of imaginary, but also based on very common use patterns for multi-user database systems. The core of it all is a PostGIS database in Cloud SQL, and you can have field personnel connecting to that PostGIS database from mobile devices, maybe people in the office connecting to it from QGIS to manage the spatial data, and possibly project managers also working on that database, and they're all working on the same database from different clients in different places and doing different things. And that's the beauty of PostGIS, is you can have multiple people editing the data at the same time. And then we have our BigQuery instance, and that's pulling data in from Cloud SQL using a shell script that updates it at 3 p.m. every day after all the field personnel have entered their data and project managers have had time to review it. Then it's moved from our working database in Cloud SQL to the production database in BigQuery. And so we talk about writing this script and scheduling it as well in the course. And then we have Data Studio, which is what the clients or maybe even project managers that don't want to use GIS are using to access the data. And that data in Data Studio is being refreshed from the BigQuery database depending on your needs. It could also be updated directly from the working database, maybe for project managers using a dashboard in Data Studio that the client won't be able to see. So we can have different data sources feeding into Data Studio, and we discuss this entire workflow throughout this course. Collaboratory is another Jupyter library environment like Data Lab, but it's a lightweight product focused on learning and collaboration. You can learn the methods easily and share notebooks and collaborate with other people, much like you can with Google Docs. It differs from Data Lab in that Data Lab is running on its own virtual machine whose resources are totally dedicated to your needs, so it's no problem if you need to run some kind of massive neural network model on your data, and you have all of Google's cloud tools available for security and access management. And something like that might be a little too much for a Collaboratory, which has to share resources with other users. Google Earth Engine is something that I think is unique for Google. It's an online catalog of massive amounts of satellite imagery and other data types for the entire globe that you can access and analyze using Google servers. So you don't need a powerful computer or expensive remote sensing software or spending time and money to acquire satellite imagery. And it's been a total game changer in that field, and there are many Udemy courses on Google Earth Engine that you might want to explore further. In this course, we just briefly get started and focus on interaction with other Google services. And finally, Google has some APIs that you can use to access geospatial information through HTTP requests. And we'll cover the basics of each to get you started and demonstrate how to make requests using both Python and JavaScript, and how to interpret the results. So this includes Google Maps for map tiles that can be displayed on a web map or a mobile application, or even as background maps in desktop GIS. Geolocation will return a latitude and longitude from a street address or vice versa. Routing will return turn-by-turn directions between 2 points for going from one place to another. The Elevation API will return the elevation above sea level for any location on Earth. And the Places API returns place names and information about the places that are near a specific location. And there are other companies that offer similar API services, including Microsoft with their Bing APIs. But Google is by far the most used and, in my experience, orders of magnitude better than other services. For instance, Google has geolocated street addresses for me that were incomplete or had spelling mistakes that no other service could get a result for. Okay, that's what this course is about. If it triggers your interest, please consider going to udemy.com and signing up for it.